All right, so welcome everyone to Cloud Computing and Big Data, our parallel scalable machine learning and deep learning course. Today is a practical lecture 5.1, understanding MapReduce, and of course in our context specifically in cloud environments for cloud applications. And before we go into the material of this lecture, and I show a little bit of the Amazon Web Services, let us review what we learned the last time. So we looked a little bit on the MapReduce computing paradigm, which was essentially borrowed from traditional computer sciences in the sense that there was always a divide and conquer approach already existing. This is a very traditional paradigm, how you solve problems in computer science. You will see in sorting, in many different areas in computer science, you will always have this divide and conquer strategy that you see here on the top, where essentially a big problem that is not so easy to solve will be broken down in smaller problems, which are easier to solve. And we call that a partition step. And then basically you combine all of the results of these different, let's say, more intermediate results or smaller problems, then back to the big problems. Of course, we also learned that this has limits. So you would say that the communication between all of those should be relatively, let's say, low. So when you compare this now to weather prediction, as was one example, where essentially every second, basically the world around us affect the other world around us, if you would cut it down into these different pieces, we would need heavily to interact, of exchanging all different sorts of physical parameters, of having, when we do water simulation, we would probably propagate the wave height in every little second. So here, this is a different problem. We talk about this in the terms of high throughput computing approaches. Here, you just basically crunch down the problem. You don't want to have very many interactions then. You just basically give it to solve it, and then in the end, pick the result. So here, it's a very important takeaway message that MapReduce is not so much for iterative approaches for numerical physics, for basically numerical methods used in physical laws, in all sorts of simulation sciences that we do actually in the HPC course, which is complementary to this course. But however, we have seen also that the MapReduce approach then, based on this divide and conquer, is a very powerful approach. However, having still one little gimmick for us here, so to speak, which actually brings us something which the framework provides us. And this is an extremely powerful component. Not only is all the communication from where to what I have basically to transfer the data gone, it also has some certain functionality, which we would say is group shuffling and sorting. So in a way, when you think of what MapReduce really is from the framework point of view, then you basically have a framework that does map, in the next step, group, shuffling and sorting, and then reduces. And these grouping, shuffling, and sorting is based on so-called keys. So basically, we talk about key value pairs, how you define essentially map tasks in context with reduce tasks. And also this we will review today. And also I show you some example in the cloud, if that works out with the cloud. Otherwise, we have some, let's say, traditional parts also here in the slides that show you how it works. In the end, you will see also in the practical demonstration, is this really just the lowest level of a lot of different applications. So you see MapReduce and Hadoop, which is the implementation of MapReduce in the Java world, just gives us parallel task execution. And there are a lot of things around it. And one of the most important things we said is a complementary part is this HDFS, the Hadoop distributed file system. So these are also in the Hadoop implementation provided, but enable a lot of different applications on top. So we have different Apache open source components which actually build on top of Hadoop, which makes it so powerful. And you will see that when you go to Google Dataproc, when you go to the Amazon Web Services in terms of the Elastic MapReduce that we will discuss today, or if you go even to MS Azure with all the Apache stack and Hadoop stack, always you'll find these Apache Pick, Apache Hive, Spark, Hadoop, all these components very close together. HBase is there essentially for NoSQL stores that we have already a little bit elaborated. So you will find always a very large stack. With this comes challenges. You will see that essentially all of these are different versions. The versions should match the underlying MapReduce version, or basically also to the different Python or /Java versions. So in a way, to host this stack, if you create your own cloud, is not at all trivial. You have to bring all the different versions in a concrete manner together. But the key message why we wanted to use this was to have it very simple, right? In the cloud, we're thinking about not anymore doing like we do in HPC, different communications from this core to that core, or we want to transfer data from this node to that node. That's what we do in HPC, very low level work. But here we have seen that on the one hand, we have a computing paradigm that lets us define very easily map tasks and reduce tasks. And on the other hand, you have seen with the Hadoop distributed file system, which is here on the right-hand side, we have a very interesting method of abstracting away all the complexities of file systems. We have some guarantees against errors and failing. When we have, for instance, replication enabled, you see here that basically block 1 of a data set is here essentially available 3 times. And if one data node fails, the map task and the reduce task are able to work on this data chunk 1 still. And in order to do so, you do a technique called sharding. You have a big data file in terms of terabytes or 100 terabyte, whatever, and you chunk it into different pieces. And then the framework makes sure, based on your replication policy, that actually the data is then really distributed across your different clusters. And that makes it really, let's say, fault tolerant. And the whole framework then will basically resubmit jobs that failed and will look where the other data set that is maybe replicated. So this is basically the key, most important components. Of course, we could do a whole lecture, as you imagine, now diving into HCatalog or HBase with NoSQL stores could be 2 or 3 lectures. Mahout for machine learning is complementary to things we have already learned with scikit-learn, or also that we used with Apache, the MLlib, if you remember a little bit from the earlier lectures. But of course, here we focus a little bit now today on how you would install or deploy such a cluster essentially in the AWS cloud. So it's one of the additional practical lectures which usually should be related to your assignment. However, this time we didn't really manage to do that. I'm sorry for that. It was a bit surprising that Amazon changed to AWS Academy just, let's say, a couple of weeks ago, which basically changes a whole program of assignment 2 and all of this lecture for you. However, the key services are still the same, but the approach how to do academic and student support is fundamentally changed with certification more in an industry fashion. So there was no quick fix to repair that. And I can tell you that in the forum from AWS inside there, we already, as professors, have a very long list. So there were many of my colleagues that already have actually filed complaints that we cannot use the AWS EMR service anymore because the Educate program has stopped. Anyway, so that's just something we have to live with, and in a way gives you also a message how clouds work. When I think about that, the evolution is constantly evolving. You have seen MS Azure suddenly change a lot of things. AWS is changing a lot of things. So they keep track with the market. They basically look what could be competitive. Here and there, I'm not fully understand why they stopped the Elastic MapReduce service, or basically why non-cloud vendor in the open space is actually providing this. So if you go to Google Dataproc and the free tier, you will also find that there's no MapReduce service for free, like it was for 2 years ago. Or basically MS Azure, essentially the same thing. HD Insight is just stopped. So it could be something to do with Bitcoin mining, that the people are scared that the people use too much free computing. But on the other hand, it gives really bad impacts in teaching. But here goes the disclaimer and the complaints about that. Let's get constructive and focus on what we have. And of course, when you swipe the credit card, Amazon Web Services is fully on. And that's what I did. So show you a little bit how it works. So again, just a short revisit. We have already talked about it. Basically, this is now a large open source community. Apache Hadoop is not standing anymore alone with the MapReduce framework. It's basically lots of different tools and technologies. Important is that it has also a scheduler, really to schedule all the different jobs to the different, let's say, data elements that we have there. We discussed also that divide and conquer is essentially the key essence in this. And you would find some, let's say, complementary additions to the traditional MapReduce by adding here, for instance, some pre-combining steps, which has something to do with when the data is written to disk. So with the initial combination, you maybe can already do a more meaningful way. But these are really, let's say, small additions people have done. If you remember, we talked about the limits also an iterative MapReduce. There's something like HLoop, for instance, that is actually more focusing and kind of tuning for more iterative MapReduce approaches. And of course, when you think about machine learning, that's what you need. If you remember when we had the Apache HD Insight, or essentially our idea in the Google Cloud to do is always logistic regression, what we did was an iterative optimization through the SGD optimizer, and this would require another submit of the job of the SGD. So in a way, machine learning nature is very iterative to come to the, let's say, convergence of the algorithms, but that's also something what probably the other machine learning course, which is complementary to this course, is teaching. So long story short, Amazon has around 300 services, and it's really hard to keep track of those. You would say every week is a change in one of these essential services. Every week there's a new service or something new can be tried out. When you go just to the website, you will see an amazing, huge package of all sorts of services. When we now look a little bit on the focus here with cloud analytics, data analytics, what we want to do in this cloud course, you see a couple of more different services which are relevant. You see them here on this particular website, where Amazon EMR is, of course, the one key one to do the computing. But when you have very special needs, you see there's a search service for Elasticsearch. For streaming data is Amazon Kinesis. There's something like business analytics and data warehouse, which people do in industry a lot for QuickSight and Redshift. They're all different products, all cloud products, and on different areas of the stack. We will learn in some of the next lectures coming up about infrastructure as a service and platform as a service and software as a service. And here you see them essentially being on different elements on the stack, and we will come back to this classification later. However, in order to have practice for your assignments and to really understand early some more practical parts, we really wanted to introduce this a little bit. Once again, AWS Educate just spontaneously decided to go to something called AWS Academy. And although we are registered and they tried hard to make it work, it seems like we need to do some other certifications first, which means a complete other cloud course in AWS space in order to get even to something where we can use Amazon EMR. So in a long way, this means we cannot really integrate it nicely in university teaching anymore. And on top of it, here and there are also payments to do for some certain certifications. On the other end, of course, it's nice that now training and certification is recognized by some industry vendors, where we probably in the next years will look a little bit of students that want to maybe do a little bit more in the cloud course and then get a complete training and certification from Amazon. So if you are interested here in the course for that, let me know. Maybe we can do something. Although I have to say, the forum is full of complaints and says essentially it's very new. Everybody doesn't really understand it from the user perspective, and I think things need to be sorted out. But essentially, the key idea behind it is not so bad. I think having a more industry recognized part of that is very good, but having then a complete course just by Amazon is of course not possible for a university. Universities need to be, vendor agnostic. We have to be not locked in by one vendor and can say, well, the cloud course is just using AWS, AWS web services. Here, the goal is, of course, for university to use all of the different ones, or at least to show students a bit objectively what are the benefits of moving from this or that cloud. So also this particular path forward of just using AWS Academy as a university lectures is also not what is usually practiced. But I think they come around that very quickly, and we will, of course, also take more discussions with them. Maybe there are also options of having sub-courses or so. In the end, it was just too spontaneously. As I said, a couple of weeks ago, I got the email, and essentially in that point of time was no way of also integrating this in the course. However, in former times, there was something like this existing. And you see here a little bit how the AWS Academy Portal works. You would sign in. And you see here that essentially there's to be different parts that you really need to take in order to get to further services. So you have to first do the Academic Cloud Foundation as an accredited course. And then if you want to do a bit machine learning, what we do here and combined with the big data aspect of the course to really make use of big data, you do another course. And then using technologies in a lab, then you need another course. So you see, essentially, this would be quite an AWS dominated class instead. and I don't want that. So in the idea of how it was before, and maybe we go back to this, I think many university professors have complained that this is stopping. So maybe we get back to this. You see here how that worked previously very nicely, where we just created an AWS Educator classroom. Here's the one from last year, and everybody from us and the students and the teachers, professors got some small amount of credit. We don't want to have millions. We just want to have a little bit of money to have credits to just trying some services out, like the Elastic MapReduce. Of course, you still can use here and there with the AWS free tier some resources. I come to that in a moment, but here it was very nice as a classroom setup. And as I said, the MapReduce is a very unique service, very powerful for clouds, and I think it should fill the curricula of all cloud, basically cloud lectures, and that's why it's so important to teach that. So students got at that time, an email. That's of course something which is something that should be kept, that students are really registered and then can accept the invitation and get, let's say, to the AWS space as a student in a specific environment. It was a limited environment, but still it was good enough. As you see here, the Elastic MapReduce service, for instance, was available last time in the Educate starter account for every student to use. And of course, they were just recorded in some, let's say, specific regions. That is also something what we want to explore today in the demo. What are these regions and what they mean in AWS Web Services? So in the end, it's also a bit funny. I just do this in an anecdote because I'm a bit annoyed that this is actually stopping. But you see here, my credits are actually apparently still limits for a couple, actually available for a couple of days. But this, of course, is a screenshot from last year. So at that point in time, it's not anymore valid. I couldn't create another class. And from this, we are just bound to not giving any direct hands on MapReduce this year, for which I apologize in a sense, but we also will work in the next years to get this back again. Maybe in other cloud providers if AWS doesn't provide it anymore. But yeah, as I also can tell from the, let's say, from the work I did in the last week, all the different cloud providers don't provide it. So we have seen HD Insight is not anymore provided in the academic version. We have seen essentially that the Data Proc service from the Google Cloud Platform has lots of services to offer for free for education, but not actually the one that is then this Data Proc with all the Hadoop and MapReduce. So in order to look a little bit what we want to do in terms of the AWS service, when you log in, you basically have here your billing, you put in your credit card in your account. You have a certain portal that you see here where you have lots of different cost elements that you can actually look at. And in the payment methods, no surprise, of course, you would have here the credit cards and so on that you have, and then essentially can, swipe with this a credit card and now have, basically the money to, deploy clusters, to allocate budgets. So you can really do a lot here with these cost explorers, looking and basically managing all how much you spend per month. As I said in earlier courses, of course, the cloud always runs 24/7, so to speak. So even if you log out of this console, actually the services keep still running. And this is something what we can see. Again, when we basically go to all services, you see here again, lots of different options. As I said, the 300 services, because all of them have also their varieties, how you connect them with each other. You have very different areas available here. And this is also something what I, of course, keep track here in the basically in the presentation, which is associated. One central one, and of course you can search for it. One central one, which we will see and have already elaborated in the earlier lectures, was this Elastic Compute Cloud service, which just gives us virtualization and virtual service in the cloud that we had also discussed in one perspective with the benefits of virtualization behind it. And when you now look and basically have EC2, you can also do a lot of elements here and create computing resources. But this is something what we will do in one of the infrastructures or services lectures. I don't want to go into the details right now, but if you look on all the other areas that you see, just here on the slide, maybe you see database, migration, transfer, quantum technologies are starting, Analytics, what I already said, Elastic MapReduce is one part of it, but then Kinesis, data pipelines, and so on. They're all different services. And this was an older situation. When you now log in, you will also see that when you come to the services again, you see more and more. Particular machine learning in the last couple of years was getting massively stronger, as you can actually see here. There's now many different services that we actually come back to in this class again and again, but also other actually applications have been really advanced. And basically you see also that we have still, of course, the possibility of using the Elastic MapReduce. It's just dropped out, so to speak, out of the educational sector. But before we do this, there's some side remark. And firstly, of course, when you have computing services and you want to create them, remember you have your credit card swiped, or basically it's inside the system, right? In other words, now the payment will start. And when you now use an EC2 service and you will pick, let's say, one of these resources, you see here a very powerful CPU really with a lot of, let's say, a different money attached to it. So we're talking about of $2.80 per hour, but of course that can quickly accumulate, right? And as I said earlier to you, this is, let's say, not very much terms of, basically memory. If you want to deploy a Spark cluster, we have seen in the MS Azure platform that was expensive. But when you go now and want to do, let's say, the Elastic MapReduce and you want to use Apache Spark with it, here you want to have, of course, large memory sizes, right? So a more powerful GPU, but also here the key point is the memory, and here you go with the price, right? $26 per hour compared to $2 per hour. So immediately, when you have a big Spark cluster and you want to have lots of worker threads that you remember hopefully from one of the previous lectures, then you really have quickly accumulating costs in the hundreds per hour. And of course, then being said that some of the jobs basically maybe require 24 hours to run, you can multiply by the usage. And of course, this is something to really come back to again in infrastructure as a service, just to give you a sneak preview that, of course, everything we do here in the online demo is costs, right? Almost everything, every service we use, there are so many of them, but of course, all of them are associated with a cost. There's a certain principle in this infrastructure as a service, and that is called secure shell access keys. This is something where you have basically a public-private key pair created in order to access these services in the cloud. It's a very secure mechanism usually used to actually access these systems in the cloud. So we have to look a little bit on this and configure some of those when we want to use, for instance, EC2 services. And you see how that works here a little bit with this SSH key pairs. So you would create them with something like MobaXterm is an SSH client, or you can also use PuTTYGEN. It doesn't really matter. What you get essentially is a private and a public key. While you upload the public key to the cloud, right, that you see here to the EC2, you would remain and keep the private key local on your laptop. That's very important. And every time you actually will log in from your system to the cloud to one specific server here from these EC2 instances, you will present your private key, and basically the public key will be matching and in this sense get access. If you don't have the right private key, you cannot access the cloud anymore. Hence, what we want to do here in the first demo really essentially we want to create a key pair, and you see that this is quite very quickly to be done. There's a security area here where you have key pairs, and no surprise to you, I already created two RSA key pairs that you see, Morris key pair, Morris new key pair. They also play a vital role when we want to create Spark clusters and MapReduce clusters later. So, and this is very just straightforward done. You can pick the different types of the key. It's just the algorithm that you can basically use there. And then when you see key pair, Morris very new as an example here, then you have a new key pair automatically created that then will be available in the cloud. But of course, as you know, we also want a private key downloaded on our system, right? And this is something where we now create the key pair and hopefully can download, as you see here, this private key pair on my desktop. So I have now the private key pair on my desktop and the public one is in the cloud, and have created this key pair, not big rocket science, but it is important that these keys usually stick to these different locations that you see here. We have seen that only some certain areas are, for instance, here and there supported for certain services. This is something to always remember and look at if you work in AWS, in which region you are just in the moment on the top here. This is all essentially also on these slides. So what I just said, and of course, then you can go ahead and create maybe an EC2 instance when you just want to have bare metal, or you basically go to more advanced services. And when you want to then log into essentially this particular service, you basically need to have an SSH client, and you get essentially the URI basically from the link here if you want to install it, want to try it out. It is a very powerful SSH client that then can use your private key on your laptop to connect to the cloud. But the Secure Shell is also a very low-level way of connecting. I think some of you know that. So in a way, that's not what we want to do. We want to have a Jupyter notebook and so on, which I show you later. Just at the end of the first part of the course hours here, of the first part of this particular lecture, you have seen now essentially that AWS is very powerful, but of course people make it even more powerful by the AWS marketplace. So if you go there, you will find very specific prepared elements already in use by many different companies. You would say Airbnb was basically a startup company once, right? As I said earlier, also Angry Birds, nobody know them at some point in time. Now, of course, everybody knows Airbnb, especially in Iceland, or Angry Birds having movies, games, and whatnot. But of course, they scaled up with the cloud, with the number of users, with the number of hotels, which are basically available. And the same is actually true for startup companies like Spotify, which is not anymore a startup company, right? So they had lots of songs that need to be stored somewhere with license information with it, and actually used Amazon S3. So they are basically users of the AWS by large degrees. And also here we see they use it definitively for different purposes, while Spotify, for instance, takes the S3, the scalable storage here. Basically, the Airbnb is using the Amazon Elastic MapReduce I talk about today to analyze really 50 gigabytes of daily data daily, really, for all the hotels and the bookings and so on. And of course, they can scale up, can scale down. Now it was really a benefit in COVID that they can quickly scale down their resources, because apparently many people didn't book so much anymore, or maybe people start stopping offering hotels. So a good example where this business could just easily scale down, don't use so much Amazon EC2 resources anymore. And now, as COVID-19 is hopefully not really over, but in control, let's hope for that, then Airbnb can quickly scale up the EC instances they need again, given the elastic nature. Would have been, would they have been buying big hardware resources in their own premises, in the cellar somewhere, then it would be idle all the time. They would have bought it, the costs would have been there. Now basically had a, let's say, like a situation of scaling up and scaling down. And this is, of course, one of the benefits of cloud computing, to have basically peaks in both directions for usage or basically for non-usage, really nicely addressed. We will talk about more of these capabilities essentially in lecture 8, where we then really think about the infrastructure as a service model much more in detail. And essentially, this is also already all I wanted to leave here in the first part of the lecture. Maybe just a couple of more demonstration. If you see here the EC2 dashboard, you can launch here certain instances. And of course, when you do this, you always have to pick an operating system with it. What should be deployed on essentially a really computing entity. EC2 is computing, but computing alone is not really usable. So we need an operating system. And remember what we had in virtualization in one of the lectures. This is, of course, then completely in a virtualized environment. So you could also then nicely combine the different, SUSE and Windows operating systems here, because essentially this is something where virtualization gives you then the power of really decouple all of these different implementations. You see also that there are specific environments or AMIs we will come back to in lecture 6 and 7 already next week when we do deep learning. So the cloud also supports that with specific packages like MXNet, TensorFlow, PyTorch, specific CUDA, Nickel, and cuDNN libraries, Intel libraries, which are specifically supporting deep learning and, let's say, machine learning at scale. But this is, I think, just a sneak preview of also the infrastructure as a service, which I will tell you about. And then when you once select one, you essentially come then to the next choice, where I said earlier, we have basically now to choose what type of CPU you really want. You see you have lots of those available here. And of course, all of them are associated with different costs, as we have seen, especially if you talk about high memory. We learned in earlier lectures, memory is very, very expensive. But required if you want to do elastic MapReduce, and this may be via PySpark or Apache Spark, then of course you benefit from this. Right, so I think that's all for the first part. Basically, we start with the second part in 10 minutes.